Hi there, this is Dr. Pan recording from Tucson, Arizona. Thank you for watching this clip on implicit differentiation. We're giving a form here and we were supposed to find a dy dx or y prime here at a specific point. So in order to find this one, now first couple of comments on implicit differentiation. For this particular problem, we can actually solve in two ways to find a dy dx, and that's probably a good idea to go through this and show you why we use implicit differentiation in the first place. Okay, so for one, let's solve the regular way. If we have a y half is equal to 6 minus 9 and radical root of x, if I can express y solely with the variable of x, this is called explicit. Okay, so if I can express y in terms of x, I can take a derivative pretty easily from this one. As I said, not all the problem we can actually have y expressed in terms of x. For this particular problem, we can do both, and that's a good idea to see why we do what we do. All right, dy dx here, we're going to use chain rule, power rule first. 2, 6 minus 9 radical x. I'm going to take derivative of this term, which is minus 9. And then the x is really x to the half, so times half times x to the minus half. It's pretty messy, but you gotta do what you gotta do. Alright, so let's simplify a little bit over here. This one cancels off, so I have a minus 9. 6 minus 9 radical x. This one is really radical x. So I'll just leave it here. I'm not gonna bother to rationalize it and make it pretty, but let's leave it here and let's see what we're going to do implicitly. Okay, so either we're too lazy to have a y into this form, which could happen sometimes, or we're unable to express variable y explicitly just in terms of x. So let's see what we do. It's pretty easy to start. We're going to take derivative against x on this one. So I have 9 over 2 x to the minus half. Now I'm done. Okay? Because partial x against the variable x itself is just a 1. Next one, I'm going to take derivative of this one, except one minor difference. This is a plus y to the minus half. Then I'm going to do dy dx. The reason is I'm going to say y is an expression of x. So basically, think of those Russian dolls. They're nested together. So you're going to pretend y is just an outside layer. And the inside layer, it's a function of x. That's why you have this term, dy dx, because y is a function of x. This equal to 0. And what we did just in the last step, it's called implicit differentiation. So you just, without cleaning it up, you just start operating on the equation here. And when you get to the variable y, I always tell my student, put some sort of marking on it to remind yourself when you take derivative of y, you have to have dy dx using the chain rule. And it implicitly implies that y is a function of x. Okay, so if you can get this step, 90% of your headache is over with. All right, from here, we're going to dig this one out. So we have half y to the minus half dy dx. I'm going to move this thing over. Equal to minus 9 over half x to the minus half. Okay. I want a dy dx by itself. Dy dx is equal to minus 9 over half x to the minus half. Now you notice I'm not bothering to do much simplification other than just writing everything down to the form I wanted. Minus 1.5. That's not a pretty one here. Alright, now let's simplify it. We're going to clean up those stacked fractions. Minus 9 over 2 multiplied by 2 over 1, reciprocal. Okay, x to the half, it's on the negative, so it's on the bottom. This one was on the negative, become positive. It's radical of y. Okay. One more step there, and from there you should see it's exactly the same what we started with. From this original equation, I know radical of y is equal to 6 minus 9 radical of x. Okay, so I just substitute it back in there. divided by radical of x. Now compare those two. You see they're exactly the same. So it looks like all roads leads to Rome. So it doesn't matter which method you use for this particular problem. If you can actually express y in terms of x, then you have two methods. Now from here, all we really have to do is give us a point of 1 and 4. So dy dx evaluated at a point of 1, 4 is equal to, let's be careful, minus 9. 6 minus 9 times radical 1 divided by radical 1. Okay, so minus 9 times 6 minus 9, which is minus 3, and it's positive 27. Okay, so that's the answer. All right. Well, that's how we solve implicit differentiation. Hope it's clear. Please leave a comment on YouTube for this video and let me know if it helped you or if you liked it. Till next time, have a confident day.